Rates of chemical reaction. Factors affecting rate of a chemical reaction. The rate of chemical reaction depends upon the following factors. Those are concentration, temperature, catalyst, light, surface area, and nature of reactants. We'll discuss all these factors one by one. The first factor is effect of concentration on reaction rate. The rate of reaction increases as the concentration of reactant increases and vice versa. This rate is directly proportional to concentration of reactants. This effect can be explained with the help of collision theory. For a reaction to occur, the reactant molecules must collide with each other. The probability of such collisions increase with the increase in concentration of reactants. Hence, more is the number of collisions taking place per unit volume, more will be the rate of reaction. To understand this, we'll take a chemical reaction, that is zinc reacts with dilute sulfuric acid, then zinc sulfate aqueous solution is formed, and along with it hydrogen gas is released. Now on increasing the concentration of H2SO4, the rate of evolution of hydrogen will increase. Different reactants can affect the rate of a particular reaction to different extent. It can be explained with the following example. 2NO in gaseous state, that is nitric oxide, when reacts with oxygen gas produces 2NO2 gas, nitrogen dioxide. The rate of this reaction becomes double when concentration of O2 is doubled. The rate of this reaction becomes 4 times when the concentration of NO is doubled. The next effect, that is effect of temperature on reaction rate. Generally, reaction takes place much faster at a higher temperature. It means on increasing the temperature, the rate of reaction is increased. Hence, rate of reaction is directly proportional to temperature. For example, calcium carbonate. Solid reacts with hydrochloric acid, dilute, forms calcium chloride, aqueous plus water, liquid, and CO2 gas. At 273 Kelvin, the evolution of CO2 is very slow, but at 323 Kelvin, the evolution of gas CO2 gas is rapid. At 270. It means as the temperature increases, the rate of evolution of CO2 also increases. Rate of most of the reactions become double or triple on increasing each 10 degrees Celsius of temperature. The reason is at higher temperature the kinetic energy of reactant molecules increases, due to which the number of collisions increases, which increases the rate of reaction. The third effect on rate of reaction is effect of catalyst. A catalyst is a foreign substance which is added to a reaction mixture to change the rate of chemical reaction, either increases or decreases the rate of reaction without itself undergoing any change. A catalyst is recovered unchanged in mass and composition at the end of the reaction. A catalyst provides an alternate pathway to a reaction in which activation energy of reactants is lowered. Just for example, in the decomposition of potassium chlorate KClO3 into KCl and oxygen, catalyst MnO2 is added. MnO2 acts as a catalyst to increase the rate of the reaction. Here it acts as positive catalyst. In another reaction, that is decomposition of hydrogen peroxide, that gives water and oxygen. Catalyst glycerin is used. Here glycerin inhibits the decomposition of hydrogen peroxide. Hence glycerin acts as a negative catalyst. That is, it decreases the rate of reaction. Hence, catalysts can have both positive and negative effects on the rate of a chemical reaction. Nature of reactants. Rate of reaction depends upon the nature of reactants, physical state of reactants, size of molecules, nature of bond present between the atoms within the molecules. Rate of reaction depends on all these things. The next factor is effect of light on reaction rate. There are many reactions whose rates are influenced by light. Those chemical reactions which are carried in presence of light are known as photochemical reactions. For example, photosynthesis reaction in plants in the presence of sunlight. Here CO2 and H2O reacts in presence of sunlight in presence of chlorophyll, produces glucose, oxygen and water. When silver bromide is exposed to light, it breaks into silver and bromine. The last effect is effect of surface area of reactant. Rate of reaction is directly proportional to the surface area of the reactant. That is, larger will be the surface area of the reactant molecule, faster will be the rate of reaction. Just for example, iron reacts with hydrochloric acid dilute. The product formed is FeCl2 aqueous, that is ferrous chloride, and hydrogen gas is released. In this case, if metal is in powdered form, then the reaction will take place rapidly than the taken in a ribbon form. So it is a common observation that small pieces of wood burn more rapidly than large logs of wood. That is another example in which surface area of reactant is affecting the rate of reaction.